System of nonlinear equation in two variables. Let's take a look. System of nonlinear equations. Sometimes we will call that nonlinear system. So the nonlinear system is a system of equation contains at least one equations is not linear. So what is linear equation? Let's recall. The linear equations is an equation can be written as ax plus by equals c form, right? So nonlinear, that means you have an equation cannot be written in this form. In two variable, that's in the 2D case, so the solution is an order pair. And in this order pair, x, y is an real number, and this x, y satisfy both equations in the system. In the linear system, we learn about, we have different methods to solve the system. We do have elimination method, or sometimes we call addition method, okay, or substitution method. And we did mention that in this methods, it really doesn't matter which one you're choosing to solve the problem, they both work. But in the nonlinear system, you might see that sometimes one of the methods might not work. So you really need to take a look at the problem and decide which method you're going to use. For instance, let's take a look at this system of equations. X squared plus y squared equals 10. So there's a circle with a center 0, 0, and radius is square root 10. Another one is 2x plus y equals 1. And this linear equation. But we have one equation is nonlinear such that this is called nonlinear equation system. Well, in this problem, indeed, we can use both method, the substitution method or elimination method. Let's take a look. We will use the substitution method. Well, my mistake, indeed, this problem, you cannot use the elimination method, because when I go back to take a look of the equation, you see, this is x squared, this is not x squared, and this is y squared, this is not y squared. They are not like terms. You really cannot eliminate them by simply adding or subtracting them. So the only method we can use is substitution method in this problem. What's the substitution method? You need to pick up an equation, solve for one of the variable in terms of the other variables. If you take a look at equation 1 and equation 2, equation 1, no matter you solve for x or y, you have to have the square root, and applying but the principle of square root, then you need to have the plus or minus sign in front, which means you have two equations. It seems like it's not a convenience. Let's take a look using the equation 2. So for maybe y, okay, use equation 2. So for y, then we get y is equal to 1 minus 2x. Then we call this is equation star. Equation star is coming from equation 1 or equation 2, so I need to substitute equation star back into equation 1. X squared plus y, I can use 1 minus 2x squared, right, equals 10. Continue to simplify that. Expand this perfect square plus 1 minus 4x plus 4x squared equals 10. Combine items, 5x squared minus 4x, move the 10 to this side, so it will be minus 9 equals 0. Let's factor them. So x plus 1, 5x minus 9 equals 0. By the zero factor properties, I can set each factor equal to 0. So for both equations, then I get x equal to -1 or x equal to 9 feet. Okay, be careful over here. For each x, we need to find the corresponding y. Okay, so when x equals -1, I go back to equation 7, equations star, not 7, to find what the y is. Y is equal to 1 minus 2 times -1, which is 3. Okay. Remember, the equation's solutions are order pair, so this order pair we found is -1, 3. So when x equals to 9 feet, y is equal to 1 minus 2 times 9 feet, which is will give us -13 feet. So then we found another order pair, which is 9 feet and -13 feet. Those two are the proposed solutions. Every time when we want to conclude our solutions, then we need to check, right? So let's check each of the order pair. When you check a solution, always put them into your original equations. Right. So let me check the first order pair first. From equation 1, I need to check, is it equal x squared plus y squared equals 10? In our case, x is -1 squared plus y is 3 squared, that is equal to 10. Correct. How about equation 2? Equation 2, that is 2x plus y equals 1, right? So we need to check if my order pair satisfy these equations or not. Okay, let me move this paper a little above. So you have 2 times -1 plus 3. Yes, is equal to 1. That's correct. Therefore, -1, 3 is our solution. How about the other order pair? 9 feet, -13 feet. Similarly, use equation 1. That's 9 feet squared plus -13 feet squared. We are checking is that equal to 10 or not. So that one is 18, 1, 25. Move this one away. Plus 169, 20 feet. And that will give us 250 over 25. Yes, equal to 10. So the first equation is satisfied. How about second equation? 2 times x, 9 feet, plus y, -13 feet, is equal to 18 feet minus 13 feet. Yes, equal to 1. Therefore, the solution set, remember, right, we need to write it as a set, -1, 3, and 9 feet, -13 feet. What does that mean, geography in the graph? Okay, let's take a look if I graph this equation. So the first equation, remember, is circle with centers at 0, 0. Square root of 9, that's 3.1 something, and let's see, 1, 2, 3, 4, and 1, 2, 3, oops, right here, put the circle is okay, that's the circle, and this is our circle x squared plus y squared equals 10. And our line is 2x plus y equals 1. That is, y-intercept is located at 1. Right? And then the slope is -2, which is, if I go down 2, and then we go to right 1. The point, you have this straight line, and this line is 2x plus y equals 1, and you can see the line is intersecting the circle at 2 points. So this point is -1, 3, and this is the point 9 feet, -13 feet. So we have 2 points, so the line is intersecting the circle at 2 points. Let's take a look of this another examples. Sometimes we have a system, maybe both equations are nonlinear. Okay, let's take a look of the second example we are going to see today. Is equations x squared minus 3y equals 10. You can see this is a quadratic equation. Another circle, let's put it x squared plus y squared equals 50. Right. So for this problem is both method can work. Your substitution method or elimination method. Let's take a look. If I use elimination method, sometimes we call that addition method. If we chose to use elimination method, we need to decide which variable you are going to eliminate. Let's take a look at our equation. In these two equations, have x squared in both of the equations, but this one is y and y squared. They are not like term, so x squared is the like term they have in both equations. So maybe eliminating x squared will be a good idea. Alright, so if I use equation 1 multiplied by -1, then we're arriving at -x squared plus 3y equals -10. Let me copy equation 2 down. X squared plus y squared equals 50. Now if I add these two equations, combine right terms, left hand side at left hand side, that's 0. This is y squared plus 3y is equal to 40. Move the 40 to the other side. Y squared plus 3y minus 40 equals 0. I think we can factor them. This is y plus a and y minus 5 equals 0. Again, apply the zero factor property. Y plus a equals 0 or y minus 5 equals 0. So from here, y is equal to -a or y equals 5. Right? When 5y, then we need to go 5 corresponding x. You can use either equation 1 or equation 2 to solve for x. You see when y is equal to, sorry for that. So when y equals to -a, if I use equation 1 to solve for y, then we have x squared minus 3y equals 10. Okay, I'm using equation 1. Okay, x squared plus 24 equals 10. So from here, x squared equals -4. Right? Wait a minute. we are solving the equations in the real number set. In the real number set, x squared cannot be equals to negative number, right? Because that will contain the complex number, the imaginary unit. So this is no solution from here. Let's take a look when y equals to 5. What do we have? So x squared minus 3 times 5 equals 10. So x squared minus 15 equals 10. X squared equals to 25. So for x, square root from both sides, positive negative square root 25, which is positive negative 5 here. So we have x equal to positive and negative 5, which is we have two sets of equations, two sets of solutions. One is when x equal to 5, y is equal to 5, and when x is equal to negative 5, y also equal to 5. So this is a set of two. Of course, we should check our solutions. If you check the solution using the original equation to check it, right? Let's check. First, check 5, 5. The first equations, we will have x squared minus 3y. Is that equal to 10? 25 minus 15? Yes. Second equation is 5 squared, x squared plus y squared. Is that equal to 50? Correct. How about the other pair? For equation 1, we check that negative 5 squared minus 3 times 5, yeah, is equal to 10, correct. And the second, negative 5 squared plus 5 squared, is that equal to 50? Yes. Okay, therefore, the solution is this set 5, 5 and negative 5, 5. Again, you might be curious, what does that mean in the graph, right? Let's take a look in our graph. Let's grab the first one. The first one is x squared minus 3y equals 10. And you can see this is a quadratic equations. If you solve for y, that's y is equal to 1/3 x squared minus 10/3 here. And the other one is a circle, right? So I'm just going to do a approximate graphing in here. Okay, so you will have a circle, which is 0, 0 is your center, and you have a radius square root of 50. So this is x squared plus y squared equals 50. And you have a quadratic function, and which is parabola. In the so you will have vertices located at 0 and negative 10/3. So somewhere maybe right here. Let's approximate that. And you will have parabola more or less open upward, right? So that's the equation y equals 1/3 x squared minus 10/3. And these two graphs intersecting at these 2 points. Okay, so this point will be negative 5, 5, and this point will be 5, 5 right here. All right, let's take a look at one more example. And we are going to take a look at these problems. Another nonlinear equations, which is having the first equation is 4x squared plus y equals 0. And second equation is x cubed minus y equals 0. All right. Don't be scared. Even we have both equations nonlinear, one is x cubed, and eventually it will work out. Again, for this problem, I can use substitution method or elimination method. And how about if I use elimination method? I notice the y and y, they are line terms having their coefficient are opposite. So I can use equation 1 plus equation 2. Let's see what I get. 4x squared, because y will be cancelled, plus x cubed equals 0. Now take a look at that. They have a common factors x squared. 4 plus x equals 0. Then x squared equals 0, or 4 plus x equals 0. So from here, again, get x equal to 0, or x equal to -4. We have 2x, so we need to separate them. When x equals 0, maybe I use equation 1 to solve for y. So 4 times 0 squared plus y equals 0. So from here, y is equal to 0. So that's the first order pair we found. When x equal to -4, what do I have? 4 times -4 squared plus y equals 0. So 4 times 16, that's 64. From here, we get y is equal to -64. So we have 1 and 2 in here. So we have two solutions, 0, 0, and -4, -64. That's the elimination method. So for this problem, indeed, you also can use the substitution method. Let's take a look if I use substitution method, how that works. If I use substitution method, I'm going to substitute, which means I need to use one equation, so for one variable. Maybe I use equation 1, so for y, because y is only have a power as 1, right? So y is equal to -4x squared. I'm calling this as equation star. Equation star coming from equation 1, so I need to back substitute to equation 2. So then I have x cubed minus y, -4x squared equals 0. So I have x cubed plus 4x squared equals 0. See, we go back to which equation? We see that right here. Then you just go through this, you can get the same problems. Alright, so those are very straightforward problems. Let's take a look at one more problem. It's an applications. Okay, we are going to find the length and the width of rectangle whose perimeter is 20 feet and area is 21 square feet. See, when you solve a word problem, sometimes it will help to draw a picture to help us understand the relation. Okay, so you have a rectangle, and look, L present the length, and W to represent the width. So from this problem, we know that perimeter, right, is the distance around the figure. So for this perimeter, I know that I have 2L, right? 2 length plus 2 width is equal to 20 feet. That's given. And what else is given? The area. The area for a rectangle is length times width equal to 21 square feet. Okay, this is feet, this is square feet. let's keep the unit. And you can see this is what, put them together because I need to find the L, the length, and the width satisfy both conditions, which is I'm going to solve this system equation with nonlinear since this one is not linear equation. Again, call this equation 1, equation 2. Okay, let's see. Maybe I should use the substitution method. If I use equation 1, solve for, let's say, L. Okay. Then you can, subtract 2W from both sides. 2L equal 20 minus 2W. And divide by 2L will be 10 minus W. Let me call this equation star. Equation star coming from equation 1. So when we do the back substitute, we need to substitute back to equation 2. L is 10 minus W times W equals 21. So then 10W minus W squared equals 21. Let's move everything to this side. So I have the positive leading coefficient minus 10W plus 21 equals 0. Well, I can use 3 times 7, and negative of them is equal to 21, and the sum is equal to 10 equals 0. So in this case, I have W minus 3 equals 0, or W minus 7 equals 0. So W equals 3, or W equals 7. When W equals 3, that means length is equal to 10 minus W, that's 7. When W equals 7, length is equal to 10 minus 7 equals 3. It seems that if we just solve the system equation, then we have two solutions, 3, 7, and 7, 3. But this is an application if we step back to think about what we define length, what we define width. Width is the shorter side, which should be 3, right? So therefore, the width is 3. Don't forget the unit. And the length is 7 feet. All right. Okay, so that will be our system of nonlinear equations in two variables. Next time, we are going to come back to learn about the system of inequality. See you next time.